Number 4 is going to require us to do even more work. So our x's at least are opposite. I have a positive 4 and a negative 3, but those don't add to 0. And my y's are also opposite, but they don't add to 0. So I have to look and decide, do I want to get rid of my x's or my y's? Well, what would be the common multiple between 4 and 3? How about 12, right? Because 4 times 3 is 12. So I could make this a 12 and that a negative 12. How could I do that? Well, I would need to multiply this equation times 3, but this equation times 4. Right? Remember, we're going to multiply everything. So that's going to give me 12x minus 9y equals 75, multiplying everything. Then I have a negative 12x, a positive 32y, and a positive 40. Sure enough, I have a positive 12 and a negative 12, and when I add that together, that's going to be 0. I eliminated that variable. That's why it's called the elimination method. So negative 9 plus 32, I think that's 23y. This is 115. Divide by 23. I sure hope that goes in there 5 times. Let's check. 23 times 5. Yay, it does. 5 times, evenly, no remainder. Am I done? No. Again, you need to go back to one of the original equations, the top one or the bottom one. I think I'll choose the bottom one just because. So I have negative 3x plus 8y equals 10. So if I subtract 40, divide by negative 3, I get positive 10. So my ordered pair would be 10, 5. Could I have worked that problem a whole different way? Yes, I could. So I want you to remember my answer was 10, 5. So I'm going to work this problem a whole different way and say I want to eliminate the y's. They're already opposite, but what would be the common multiple between 3 and 8? Well, what is 3 times 8? 24. So if I multiplied this one times 8 and this one times 3, it would make this one negative 24 and that positive 24. So let's see. I have 32x minus 24y. Ooh, 8 times 25. I think that's 200. Then I have negative 9x, positive 24y, 30. So this time, my y values add and are eliminated. 32x minus 9x is 23x is 230. And if I divide by 23, I get 10. That looks so familiar. And again, if I come back and substitute back my x value, and it didn't matter which equation I chose, you know the answer we should get, right? So if I add 30 and divide by 8, I get 5. The same answer working the problem 2 different ways. Now, do you have to work it 2 different ways? Heck no. I just wanted you to see that you could have picked the x's or the y's. All right, 2 more problems. On number 5, I see 6 and 22. Don't like that. But at least I see opposites there. So a common multiple between 4 and 7, of course, is 28. So I could multiply this one times 7 and that one times 4. Remember to multiply everything by those numbers. So we have 42x plus 28y equals 35. 88x minus 28y equals 4. And one more time, we have opposites, so when we add them, they are eliminated. That's our goal. Here, Let's see, I have 130x equals 39. I am not liking this at all. 39 over 130. Can those be reduced? Yes, in fact, they're both divisible by 13. I know that's not a very common thing, but they are both divisible by 13. 13 goes into 39 3 times, and that goes in there 10 times. So sometimes we get nasty numbers. And are we done? No, we have to get y. So pick your poison. I'm going to choose that equation. So I need 6 times x plus 4y equals to 5. So let's see, I have 8. Oh, you know what? I think I could reduce that. So how about let's reduce that. 6 and 10 are both divisible by 2. Let's see, 2 goes into 6 3 times, 2 goes into 10 5 times. So now I have 9/5 plus 4y equals to 5. Now at this point I could subtract 9/5, find a common denominator and all of that, but how have we learned? Can we get rid of those fractions? Yes. Multiply everything by the common denominator, and we only have one. So we have 9 plus 20y equals to 25. So subtract 9 and divide by 20. Let's see, 16 over 20. I believe that reduces to not 8/10, let's see, divisible by 4, 4/5. So x is 3/10 and y is 4/5. This is another good example of why the graphing method would not be really good, because I just don't think we could get our graphs that accurate. Let's look at number 6. I don't see any opposites. So do we want to get rid of x or do we want to get rid of y? They look about the same amount of work. Your choice. I'm not going to work this problem both ways, so we're just going to choose one way. How about let's get rid of the x's? So the common multiple between 3 and 5 is 15. So if I multiply that one times 5 and that one times 3, would that be okay? Well, if I started out, I'd get 15x plus 25y equals negative 35. And I'd get, oops, wait, those are not opposites. So I need to multiply by not just 3, but how about negative 3? Or I could have multiplied the top one by negative 5, but one of them needed to be multiplied by something negative. So now we have negative 15x, negative 12y, negative 30. Now that's 0. Got another 13. We're going to know our multiples of 13. Believe it or not, 13 goes into negative 65 exactly negative 5 times. And then again, I'm just going to pick the top equation. So I have 3x plus 5y equals negative 7. Add 25 and I get 18. And x is 6. So we have a nice pretty answer. Sometimes they're ugly, sometimes they're pretty, but the idea is to, if you need to, multiply by the appropriate numbers to get opposites, so when we add, they're eliminated. Now just like on substitution we had special solutions, we have the same exact special solutions for the elimination method, because if you get something false, remember, if all the variables go away, inconsistent, no solution, meaning the lines were parallel. This is the exact same typing I had on the last lesson. If all your variables go away and the resultant statement is true, then it's dependent, meaning they were the same line. So on number 7, let's look if I have to use the elimination method. Do we want to get rid of x or y? About the same. I think I'm going to get rid of y. So let's see, if that's a 1 and that's a 2. If I multiply this times negative 2, that would give me positive 2. And that's all I need to do. So remember, multiply everything. So I have negative 4x plus 2y equals negative 4. Did I get everything? Yes. And then I'm just going to copy down the second equation. And when I add these together, not only did the y's get eliminated, but so did the x's. So I have 0, right? I add that together, I get 0 equals to 8. That's a false statement. That means they were parallel lines. That means no solution. So I'm really looking for no solution. Again, you can use the symbol or you could write inconsistent. Let's look at this one. So let's see, do you want to get rid of y or x? Which one looks easier? I'm thinking x. All right, so what do we want to multiply this one by? 5, because that would make 10. So this one we need negative 2 to get negative 10. Let's see, 5 times 14 is 20, carry your 2. And when I start adding that together, I get 0 equals 0. Well, that certainly is true. That means that these were the same line, and so you could put dependent. That would be an okay answer. You could put the same line. You could put infinitely many solutions, or I think we've been putting all points on the line.